Now we're going to be making a chase effect. And a chase is where the LED, this one lights up and the next one lights up while the first one turns off. And it just keeps going like that. So the light looks like it's traveling or chasing along here. Okay? So to do a chase, we need to keep track. We need to have a variable to keep track of which pixel is on, right? So I'm going to call this int pix. Okay? So under our loop here, there's a lot of ways to do this, honestly. I could do a for loop, but then I'd have to exist only within the for loop to do the chasing. If you know much about for loops, you'll understand that side. And so you can only do other stuff outside of it, and the for loop only ends once it gets to the end. But if we just keep a global variable, then we can have that pixel chasing while other things are happening in the code. Okay. So first of all, what I'm going to do here is do pix plus plus, and that means it's going to increment that pixel. So if it was 0, after it runs across this line, it's going to be 1. If it's a 1, it's going to be a 2, etc. Okay, now I'm going to use modulo. So I don't know if you guys remember 4th grade math, but modulo is a remainder. So basically what I'm going to do okay, so I'm going to type it like this. If pix is greater than or equal to LED underscore count, pix equals 0, right? So if I were to type that in, it's going to keep going up and up and up, right? Once it hits 86, that's the last pixel on here, right? Because we have 0 to 86. Okay, if we have 87 pixels, first pixel is 0, second pixel is 1, right? So with 87 pixels, the last one's 86. So if we're going up by 1 every time, as soon as we hit 87, right, as if pix equals LED count, which is set to 87, then it's going to set pix to 0. And then it's going to turn on that first one again. So it's going to go 1, 2, 3, 4, 5, all the way up to 84, 85, 86, 0, 1, 2, 3, 4. So it's going to keep going in a loop, right? So that's one way to do it. This is like a decent way, and it actually is pretty fast in memory. But I like to keep it a little cleaner. I like to do pix percent or modulo equals 87. And that says, let's see, so if it's, I guess let's compare the two. Okay. Pix, oh, I did that wrong. Modulo equals LED count. Okay. So LED count is 87, right? If pix is 87, which would make it greater than or equal to LED count, it's going to set it to 0, right? Pix percent equals, or modulo equals LED count. So what's 87 divided by 87? So that's 0, remainder 1, right? Or sorry, what's 86? There it is, sorry. Okay. 87 divided by 87 is 1, remainder 0. There we go. So it's going to make pix equals 0. The issue here is, let's say pix equaled 88, right? For some reason we incremented, we did like pix plus equals 2, right? So it went up 2 every time, or 3. I don't know. We had it going on some weird one. So starts at 0, and now it's like 90. You know what? We'll do that. We'll do plus 5. Pix, so it goes to 85, which is fine, right? Because that's not above that, and there's no remainder here, right? Well, the remainder is 85, right? So 87 divided by 85 is 0, remainder 85, right? And then 90, here's where these differ right here. So 90, so here it's greater than LED count, right? Pix at 90 is greater than LED count, so it's set it to 0. So it'd go back to this first pixel. Well, we might not actually want that. We might want it to increment correctly, right? So if it hits 90, it should be, what is it? So 87, 88, 89, 90. So it should be the fourth pixel here, pixel 3. So if I do this one, 90 divided by 87 is 1, remainder 3, right? So there's 3 left over. You can divide it fully once with a remainder of 3. So this is going to output a 3 here. That's one other reason I like to use pix modulo equals. Okay. So hopefully that makes sense. It's always a remainder left. So if I did pix divided by 87, that'd be 1, right? But pix modulo 87 is 1 remainder 0, and it's going to return that 0 part. It's going to return the remainder. Okay, so back to pix plus plus. So it's going to go to each one here, and it's just going to reset. So I want to strip dot set pixel color. I'm just going to make it red. I'll make it Knight Rider red. So the variable is pix 255, 0, 0. Okay, end parentheses, semicolon. And we need a strip dot show. So that's going to turn each one on one at a time. But I'm going to start uploading this now. But we're going to have a problem because it doesn't upload the one previous to it, right? And so there's a few ways to do that here. So after an increments, we could say, you know, maybe pix minus 1, turn that one off. Whoa, I should have also put a delay in there. Delay of 100. No, that'll take forever. Delay of 30. That's fine. Okay. So what we can do, though, is before we increment it up, we can turn that one that it's on off. So pix starts at 0, right? So we can turn pixel 0 off. It's just already off, no big deal. But then it's pix plus plus, so now it's going to be pixel 1 here. And then it's going to make sure it doesn't go over 87 or over 86. Then it's going to turn that pixel on full red, no green, no blue. Broadcast it and wait 30 milliseconds. And then we're going to turn that exact same one off. Okay, strip.set pixel color pix, 0, 0, 0. So we're turning that LED off, and then we're incrementing. And then we're setting it, showing it, waiting. Okay? So let's give this a try. There it goes. We got this piece of light here. Just following along. Pretty simple, right? So that's chasing right there. There's lots of ways to chase. I could have done a for loop also. So instead of all this, I could have done for int a equals 0. A is less than LED count. All right, a plus plus strip dot set pixel color a comma. Oh, that brings up a good point actually. A comma. Let's see, 255, 0, 0. Then we do a strip dot show. And then we do a strip dot set pixel color a, 0, 0, 0. And then we do our delay. So we could actually use this up there in that order. So what it does here is A goes from 0 to 87, or sorry, 86, I guess. So it goes 0, 1, 2, 3 because it goes up one at a time here, right? Okay, so it goes 0, 1, 2, 3, 4, 5, and it's showing. Oh, I guess I should put a value in that delay. Okay. So it turns that pixel on, broadcasts that out to the actual strip, and then in memory turns that pixel off and then waits half a second. And then turns the next one on, but the previous one's already off in the memory, and then in memory it turns the next one on and then shows it. Okay? So this would be better off right after it shows. Okay, then I'm going to get rid of all this so it'll actually compile. And then this is the right order here. So what I'm going to do here, once this uploads, I'm going to add another pixel. Okay, so there'll be 2 here. Int let's see, I'm going to call it PIZ. No, that doesn't sound YouTube appropriate. I'm going to call it PICS, Pix. I guess that's more confusing, but it's a little more appropriate. Okay. So Pix plus plus down here. Okay. Actually, not plus plus. Pix plus equals 2. So this is going to go twice as fast. Alexa, stop. And then we're going to go Pix percent equals LED count. Okay. And then we're going to set this to, I don't know, blue, RGB. Okay. Then we also need to turn it off once we show it. Okay. So now we should have the red one going at 1 speed and the blue one going twice as fast. So now we've got multi LEDs chasing. And once we get to NeoPixel 200, I'm going to show you how to use timers to do this instead. Oh, we don't have a red. Where's our red? Let's see, Pix plus plus, that's right. Oh, I see. Ah, okay. I did not take the time to spell these right. Guess that helps. I had 2 things on. I just copied and pasted. I didn't change it. But I think I can fix this. There we go. Now we have the blue going twice as fast. Perfect. All right. So that's chasing right there. So we have a variable that holds like where the pixel is. We increment that pixel and we show it, or sorry, we set that pixel to a color, we show it, and then we turn it off. And then we wait. Okay? So that's how to do chasing. Thanks for watching.